page 10 of lines. Two friends, Allison and Bernard, are walking along two different roads. The roads can be represented by the lines with equations y equals negative x plus 410 and y equals 1/2 x minus 100. They just gave you functions. So if you get functions in our class, you may put them in the calculator. I'm going to put the first one into the blue y1 position. I'm going to put the second one in the red y2 position. Remember, if you're going to put negative x, don't use this subtraction sign. Use this negative sign down here. Negative x plus 410. Isn't that nice that they gave us the equation with y equals in the beginning, which means we can type it directly into the calculator. If you want to put 1/2 as parentheses, 1/2 parentheses, or you could use the vertical fraction and then you don't have to use the parentheses. Number, go down to the bottom, n/d. If you don't have a newer calculator, you can use parentheses, 1/2 parentheses, x minus 100. Okay, and then we're going to graph. Okay. Alice is on the first road, which is the blue one, at the point with coordinates 0, 410. And Bernard is at the point with coordinates 50, negative 75. Now, we just did graph and nothing shows up. Why is that? Well, look at the size of these coordinates here. Remember that the default window is negative 10 to 10, negative 10 to 10, and they're talking about 400 and 50. It's off the screen, right? So looks like one thing we could do is we could change our window size to go from, instead of negative 10 to 10, looks like we need something like negative 500 to positive 500 maybe. And remember, zoom fit adjusts the y, but it doesn't adjust the x. So even if we would have done zoom fit, it wouldn't have been enough in this case. Okay, and then I'm going to graph now. And now I'm probably going to see these blue and red lines. Okay, so there's the blue road, and here's the red road. Allison is on the first road, and she's at point 0, 410. How can we confirm that 0, 410 is indeed on the blue road? Well, we could look at the table. That's probably the easiest way. Especially with two lines, it's easier to use the table. So I see here 0, 410 is indeed a point on the blue road, and that represents Allison. What about Bernard? Bernard is at the point 50, negative 75, and it says verify that that's on the road with equation 1/2 x minus 100, which is the red one. How do we confirm that? Well, what if we jump to x equals 50? Then that would correspond to the x coordinate of Bernard. So we could, let's see, jump to 50, and that's kind of hard to do doing the bottom arrow because it would take so long. So what I'm going to do is I'm going to change the step size to plus 10, and then I can get there much quicker. Look at that, 50, negative 75. So it is indeed true that Bernard is on the red road and not the blue road. Okay, what if you didn't have the calculator or you wanted to demonstrate this algebraically? Well, basically just put the 50 in here, and then the y that corresponds to the 50 for the red equation would be negative 75. You would do 1/2 times 50 minus 100, which is equal to 25 minus 100, and you could just put this in the calculator, and that would give you negative 75. So you've confirmed it algebraically, and you've confirmed it on the calculator. Find the coordinates of the point of intersection of the two roads. Okay, so this is something that we've done in previous pages. Same thing. The only difficult thing about this one is you had to adjust the window in order to see the intersection. And you can't find the intersection on the calculator unless the intersection is actually on the screen. So the first step is to adjust the window size. So we're going to go second, calc, intersect, which is that option 5 there. And then we're just going to hit enter 3 times because we have two functions entered into y equals. So the first curve, of course, is the blue one. The second curve is, of course, the red one. And the guess doesn't matter because there's only one intersection. So you just hit enter 3 times, and the intersection is 340, 70. Okay? All right. Next one, which is number 2. Find the equation of the perpendicular bisector of each of the following segments. The line segment joining 2, 2, and 4, 6. And if the line segment CD, if the equation of the line passing through CD is x plus y equals 3, and the midpoint of CD is 2, 1. Ooh, well, let's do A first, because that sounds easier, okay? So we're going to use the calculator again, and I'm going to clear out what's here. So the first one's going to be a blue function. So this will be the blue function, and this will be the red function. And so the blue function is going to connect 2, 2, and 4, 6, and that is the hardest problem in the lines unit, which is also the easiest problem in the lines unit. It's quite difficult to find the equation of a line given 2 points unless you use ln-reg, of course. So let's use ln-reg and find the equation of the line, okay? And let's see. So we'll do stat edit, and we'll put in 2, 2, and 4, 6 here. Oops, 2, 2, 4, 6. And stat calc ln-reg number 4 L1 L2 blank is the way you want it, and my equation is equal to y equals 2x minus 2. And what is the difference between a line and a line segment? The line segment doesn't extend past the endpoints. And the endpoints here are 2, 2 and 4, 6. So there's my blue line segment. So what are the instructions again? Find the equation of the perpendicular bisector of each of the following line segments. Okay, so we want the perpendicular bisector first of this blue line segment. Okay, so remember, a perpendicular bisector, you're thinking back to 9th grade now, we're going to divide this line segment into 2 equal lengths, and we're going to draw a perpendicular line through that point. Okay, so this is obviously going to be the midpoint of those two, but if you wanted to find the midpoint using another method, that's with the calculator, remember that if you do stat edit with these two endpoints and you do calc 2-var stats, x bar and y bar are going to give you the L1, L2 blank, that's what we want. It's going to give you x bar and y bar, which are 3 and 4, and that's going to be the coordinates of this midpoint. So the coordinates of the midpoint are 3, 4. And just to draw what it would look like, I'm going to draw the perpendicular bisector roughly through this point here. It's going to look kind of like this, okay? And they want the equation of this green line, okay? And remember, the easiest way to write the equation of a line, if you know at least one point, which we do, 3, 4, and you know the slope, which we kind of do too because it's perpendicular to the blue slope, is point slope form or point gradient form, which is y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is the point that you know. So the point we know is 3, 4, so I'm going to write it right there. xy, by the way, you don't fill in, right? Otherwise, it's not the equation of a line anymore. So what do you put in for the slope? Well, the slope of the blue line we just figured out by doing ln-reg through the two given points. It's 2. Well, the green line is a perpendicular to the blue line, so we do need to do -1 over the original slope to find that. So the slope of the green line, the perpendicular, is equal to -1 over the original slope, which is 2. If you put that in the calculator, you'll find out it's -0.5. So m is going to be -0.5. So the equation of the line is going to be y minus 4 equals -0.5 or -1/2 times x minus 3. Okay, so that is the answer to part A. Did they say to put it into point slope form, point gradient form? No. Did they say to put it in in gradient intercept form, slope intercept form? No, they did not. So in that case, you can put it in either form. Okay, usually on the exam they're going to tell you which form they want. CD, line segment CD. So line segment CD is the equation of the line passing through C and D is x plus y equals 3, and the midpoint of CD is 2, 1. Okay, so I'm going to mark 2, 1 because we know that. And the equation of the line is unfortunately not calculator ready, right? We need to put that in the form so that we can put it in the calculator with y equals by itself on the left side. So what we're going to do is we're going to subtract x from both sides because x plus y is on the left side instead of just y. And then we'll end up with y equals negative x plus 3. Okay? Now, negative x plus 3, negative x plus 3. Okay. If we draw the line negative x plus 3, I'm going to put negative x plus 3 here, and then I'm going to graph it. And then it's going to look like this, but oh, remember that my window is like huge now. I'm going to need to change the window back to the way it was. I could put negative 10, 10 here, or I could do zoom standard, which is option 6, and it'll go back to negative 10 to 10. Okay, now it looks more like my grid here, and I can't really tell what points it goes through, so if I do second table, I can get the points it goes through. So, oh, I forgot, I'm jumping by 10s. Now I want to jump by 1s again, so I do plus 1. Oops, plus 1, I said. Okay, and then I want to go back to x equals 1. So. Okay, there we go. Okay, so let's get a couple points. So some of the points are 0, 3, and 2, 1. We already got that one. 3, 0. Okay, so basically it's that line there. All right. Now, this is supposed to be a line segment. The midpoint of CD is 2, 1. So the midpoint is 2, 1. And it doesn't say what C and D are. Okay? So let's, it could, like, let's say that this is C and this is D. So then that would be the midpoint, right? Another possibility is like this point here could be C, and then this point here would be D, right? But it doesn't really matter what C and D are, even though they call it CD. The midpoint is the important point. So this is the midpoint. The midpoint is 2, 1, right? And we want to make a line which goes through 2, 1. So let's use yellow. So the line is going to go through 2, 1. Oh, that's terrible. Okay, let me make a different color. So first let me redraw that. Then let me change the color to this one. Okay, and then so it's going to look kind of like that, right? The perpendicular bisector. It's going to go through the point 2, 1, and it's going to have the opposite, or it's going to have a perpendicular slope to the red line. First of all, what is the slope of the red line? Okay, so the slope of the red line looks like it should be this number here, which isn't even a number, it's just a negative sign. Well, remember, if you have negative 1 times x, that's equal to negative 1x, which is equal to negative x, right? So if you ever see negative x, that's actually short for negative 1 times x. So the slope in this case is negative 1 times x. The slope is negative 1. So what would be the slope of the black line? It would be negative 1 over the original slope of negative 1. Negative 1 divided by negative 1, if you put it in your calculator, is positive 1. So the slope of the black line is positive 1. What point does it go through? 2, 1. So we know what point it goes through. We know what slope it has. So again, we can use point slope form or point gradient form. So it's going to be y minus 1 equals, because y1 is 1, x1 is 2, and perpendicular slope is 1. So we're going to put y minus 1 equals 1 times x minus 2. And 1 times anything is just whatever anything is. So it's actually y minus 1 equals x minus 2, and you don't really need the parentheses anymore. Okay, so that is the equation of the perpendicular bisector. Perpendicular bisector is something that we're going to use heavily on page 11 and 12, and that's why we went through it here. There are, as you can see, a few steps, and the steps can be done with the calculator at each step. Just to do a quick review of the steps we did, when you're looking for a perpendicular bisector, you need two things. One of the things you need is the point you're going through, and the other thing you need is the slope of the line, right? So how do you go about getting those? So to get the midpoint of a line segment, like we did for the blue one, you could use StatCalc 2 var stats, okay? And then you could find x bar and y bar. That'll give you the point, okay? To find the slope of your new line, you want to find the slope of the original line segment, which connects the 2 points given, which you do with linreg, okay? And then you just look at the a value. And then you're going to take that slope and you're going to find the perpendicular slope, which would be negative 1 over m. Okay? Then you're going to combine the x bar, y bar from 2 var stats with the new slope, which was negative 1 over m, and you're going to put it into point slope form. Okay, and we're going to work on that quite a bit on page 11 and 12, so you'll get some more practice.